We're starting an important idea called an inverse function, and in order to understand it, we're going to review the idea of a function. So, do you remember what a function was? When we put in a value for x, what comes out the other side is just a single value of y. So it is a functional machine if you get one thing out the other side. It would not be a very functional machine if suddenly two things were created out the other side. It wouldn't make any sense. Now, what an inverse machine is a machine that is going to work in reverse. It's literally as if if this was a conveyor belt, we literally flipped a switch to move the conveyor belt the other direction. So we're literally going back to where we started. Now, this is all over the next two sections. I'm going to just say it all here with this description and we'll kind of review it. So if I had the function, I've moved this function, this parabola, this quadratic function, I've moved it over two spots to be something like this, right? Well, this passes the vertical line test. This is a function because if I drew a bunch of horizontal lines, I never hit the function in two places at the same time. Now, that works because all it simply means is that any particular value of x, I only have one y, right? Well, what's going to happen with an inverse function is it's going backwards. So the y's have now become the x's and the x's have become the y's. It's literally the reverse of everything. And so it's going to wind up flipping, it's going to reverse the x and y's, and essentially what it does is it flips the picture over this horizontal line called y equals x, the identity function. It's going to flip it over top of that. Okay? Now, that's important to remember as we do this. Inverse functions are only those functions which are one-to-one. We can only have an inverse if a function was one-to-one. And do you remember what a one-to-one function was? A one-to-one function passes the horizontal line test. So, if you draw horizontal lines here, I don't pass. I hit in two spots at the same time. So a one-to-one function was this, that I only have one particular x that I put into the machine that makes one particular y. That's it. There's only one way. The original definition of a function didn't say that. It didn't say that I can't make y a couple of different ways. Maybe I put this x in and I put another x in. As long as I make one y out the other side, I'm fine. It's okay. But a one-to-one is an even more special machine. It is a machine where there's only one value of x that goes in order to create one y out the other side. Now, the reason that a function has to be one-to-one in order to have an inverse is this. If we flip this picture over that dashed line, which is what an inverse does, if I flipped it, what it's going to do is it's going to fold it. It now would look something like this. Well, what's the big deal with this? If you try the vertical line test on this, it does not pass. So if your function like this is not one-to-one, when you fold it and try to make the inverse function, when you reverse the x's and y's, you won't have an inverse function because it is not a function at all. Okay, so now that's a quick overview of the big picture. Let's start talking about it here. This first slide says we have to have a one-to-one function. And the reason is because when you invert it, if it's not one-to-one, it won't be a function at all. So only functions that are one-to-one can be inverted. Okay, now this first lesson is really the basics of how this works. They're telling us that we have a one-to-one function, and if you put 2 in this machine, you get out 4. If you put in 5 to this machine, you get out 12. Well, what would happen for the inverse machine? Well, the inverse machine works in reverse. It's literally like someone flipped a switch and has turned the machine backwards. And so now the y's are going back into the machine and you're getting out 2. I've literally reversed it. It was x went in, y came out. Well, now the machine's going the other way. And so if I put 4 in, you're going to get back to where you started and get 2 out. So the same here. The original machine, you put 5 on the conveyor belt, 12 comes out. Well, now you reversed it. So you put 12 into the machine, you get right back to where you started. Okay. So this is saying this is the inverse machine when you give this language this little inverse sign up here. This is the inverse machine of h. So what happened with h? Well, originally we put 2 in and we got 6 out. And how do I know that? Because this is going the other way around. This 6 went in and got me back to where I was started. So they're just the reverse of each other. So the original machine must have put 2 in to get 6 out. The inverse machine put 6 in to get 2 out. Okay, now we're going to test whether or not two functions are inverses of each other. And so if you think about my conveyor belt idea, here's what's happening. You put some x in to the machine and you get some y out. Well, if they're inverses of each other, what would happen is if you turn this into an assembly line, so if you turn this into an assembly line like this, where you had two machines, if you put something into the first machine, what spits out of the other side then goes back into this second machine, and it should get you right back where you were started. If this is f of x and this is f inverse of x, I put x into the machine, and what comes out now goes right back into the machine. If it's the inverse machine, shouldn't I get right back to where I started? And so here's what this looks like mathematically. We're going to do an assembly line, remember, is a composite function. So you could write it like this, or you could write it like this. You could have written it either way. But what it means is that g is the first thing in line in the assembly line. Okay? So I'm going to take g, all of g, and I'm going to drop it into the other machine. So here's what I've got. Remember, it replaces the x. So I'm going to put in all of that is getting subbed in for x. You agree with that? All of that's going in. Now I've created an assembly line. Now if this assembly line, if these are inverse machines that are sitting on the assembly line, I should get back to where I started. So let's solve this. You see the two negatives. So I put in parentheses to show that I'm subbing. But if I don't need to multiply anything, then I don't need the parentheses anymore. So I have this. Now I've got a -2 and a +2 down in the denominator. They're gone. So I have 1 over 1 over x. Well, this is the same. I'm dividing 1 by 1 over x. It's keep, change, flip. It's just going to bring x up to the top. So I put these two machines in an assembly line relationship, and what happened was I got right back to where I started. So they're inverses of each other. Now you could have gone either way. You could have built the machine like you could have put, I should do it like this. You could have put the inverse one in the front, and then you go through the f of x. It wouldn't matter. It doesn't matter which one you put first. You're going to get back to what you started. So let me show you real quick. Suppose we had built it the other way around. Suppose we had done g of f of x, meaning that I'm putting the f machine in first, which means it's going in here for x. So 1 over, so it would have, oops, it would have looked like that. Okay, well, what do I do to tidy this up? I have 1 over some fraction. It's going to flip it upside down. And now I would have this, and I get back to x. So if they're inverses of each other, it doesn't matter which machine is first and which is second. It's still going to flip them upside down. Okay, so let's try this again, or you give this a shot if you want to pause the video. I'm going to see if these two have that inverse relationship of each other. So I'm going to put them both on the conveyor belt. I'm going to make them a composite function. It doesn't matter the order I do. I'm going to choose this. You could go the other way too. So I'm going to put all of g in here for x. Okay, so I would get all of that cubed minus 4. So all of this has just replaced the x there. So all that dropped in. These are opposites of each other. I've got a cube root and a cube, and so they knock each other out. Oh, I thought we were going to have inverses, but we don't. So they would knock each other out, and I would have x minus 4 minus 4. Well, this does not equal x, so this won't work. So these are not inverses. Now the way, if you could see, what would have worked is if this had been plus 4, it would have worked. But these two, they're not. Okay, what do we got here? That's supposed to be a 1/3. Okay, same thing. This is supposed to be 1/3 x. Now, we're just checking to see if they're inverses of each other. Let's see if we can just look at their work. Yeah, that's not the way I would do it. So, okay, I'm going to put 1/3 x in. So I'm going to do f of g of x. So I've got 1/3 x cubed. Now, this is not going to make x. So if I put this guy into there, I get another one that's not going to work. This is going to turn into 1/27 x to the third, and that is not x. So these are not inverses of each other. Okay, we've had a bunch that haven't been. Let's see if we can get one that is. So you can go either way with this. I'm gonna put f into g. So I'm putting all of this guy inside of there. So I'm going this guy in for x. Now these are opposites of each other. So I'm going to knock each other out. A cube and a cube root, they're opposites. So I get this. Get down to x there. So I got x. So these are inverses. Okay, now we've talked about this. I may not have used this language. I'm assuming we've used this before. I do these out of order sometimes, so I can't remember what's happening and what's already occurred. But the domain are all the values. Yeah, we've definitely done this with functions. So domain are all the values that you can put into the machine. Range are the values that you get out. Well, this function, the inverse function, reverses all of that. So the x's become the y's and the y's become the x's. So basically, the domain of the original machine is now the range of the inverse, and the range of the original is now the domain. So if this was my original domain and this was my original range, it would be the other way around. The inverse machine has a domain of -∞ to -2 and has a range of 1 to infinity. So you know what, I should have done it like this, like D and R. So I've just reversed them. The original function had a domain of 1 to infinity, so that's the range of the new inverse machine. And the inverse machine has a range of -∞ to -2. That will be the domain of the new one. Okay, I think we conclude this one with just some table stuff. I don't test a lot on the table thing, but it's clever. So what we're saying here is I have a table that tells me about a function that's miles is a function of time in minutes. Okay, so if I were reading this table, if you put 50 into the machine, you get 40 out. Now they want us to tell them what would happen for the inverse machine. Now the only table I have is the original machine, so how am I going to read this? Well, since the domain and range are reversed, if I want to know something about this, it would be the 70 that came out of the original machine. Do you see what I mean? So this is the reverse. So this was a input of 70. Well, that's the reverse of the original machine. It was the output the first time. So if 70 came out of the original machine, 90 would be the value. So the inverse machine goes backwards. So if you had an output of 70, you get back to 90. Okay, so let's try this again. This is the forward machine. If you put 60 into the machine, you get out 50. So f of 60 equals 50. Now how about the inverse machine? The inverse machine is going the other way around. Oops. The inverse machine is going the other way around. So if you got 60 out of the original machine, you'd get 70 out of the inverse machine. All right, same thing, but we're just looking at it in the table. This table only tells about the G machine. So if we want to do the inverse machine, we're going to have to read it in reverse. So, do you remember how to just read this forward? This means you have a function, you put 3 in for x, you'd get 1 out for y. Well, this is the G machine, so we're going to try to read this whole thing in reverse for the inverse machine. We can just read it backwards. So this 3, if we're reading it off the G machine, this 3 is this one. We're reversing everything. So a 3 gets a 5. So the G machine, the inverse machine, is going to read this table the other way around. So this means a y of 3 gets me an x of 5. It's going backwards. Okay, now they've got just one more here. It's G. I'm just going to do one more here. G inverse. So the triad is just saying go back to this table. So if G inverse of 1. If I get, so we're reading this backwards. So the 1 is now a y. So if I put in 1 in my inverse machine, I would get out 3. Okay, so that's the basics. We're going to do some more complicated stuff in the next video, but that's it. The idea of an inverse machine is we're literally going to flip the switch and we're going to send the machine backwards.